The James Webb Space Telescope stands as humanity's most advanced eye into the depths of space. Its mission is not just to observe distant galaxies or capture beautiful cosmic portraits, but to decode the deepest mysteries of our universe. Questions about where we came from, how the cosmos evolved, and what secrets lie in the black voids between the stars. Designed to observe infrared light, Webb has allowed us to look farther and deeper than any telescope before it. It is a machine of monumental precision and beauty, a floating laboratory of mirrors and sensors pointed toward the edges of existence itself. For decades we've stared into the night sky, wondering what lies beyond. But now, for the first time in human history, we're beginning to get answers that not only stun scientists but challenge everything we thought we knew. In one of its recent missions, the James Webb Telescope focused its gaze on a star system located approximately 120 light-years from Earth. The telescope's powerful optics captured not just ordinary starlight, but unusual spectrographic signatures that set the scientific community abuzz. Researchers discovered a planet orbiting that distant star, seemingly just another exoplanet among the thousands catalogued to date. However, this one was different. This planet, according to the data, wasn't just reflecting light from its host star, it was emitting its own form of illumination. This glow wasn't natural thermal radiation. It bore patterns, frequencies, and modulations that bore all the hallmarks of something artificial. At first, skepticism reigned. Perhaps it was a sensor malfunction or interference. But as data poured in over weeks and months, a more unsettling truth began to emerge. The light patterns weren't random. They repeated in structured intervals, similar to how binary code might appear if translated into visible light. Some researchers even described it as the equivalent of a light fingerprint, as if someone or something wanted to be seen. These weren't just flares or auroras. This was something altogether different. Structured, intelligent, and persistent. The planet was quickly nicknamed Lumina 4b by the media, though its technical designation remains a string of alphanumeric symbols. What caught everyone's attention wasn't just the light but the timing. Every 11 hours, like clockwork, the intensity of the light would pulse, pause, and resume in what appeared to be a precise sequence. Was it a form of alien communication? Could it be a natural phenomenon never before documented? Or, in the most speculative and thrilling possibility, was it a beacon, a cosmic lighthouse built by an advanced civilization? NASA and international agencies initially remained tight-lipped. However, leaked internal memos and independent astronomer confirmations forced them to address the growing storm of curiosity. At a press briefing, they admitted that while they could not definitively say the source was intelligent, they could not rule it out either. The mere possibility sent shockwaves through the scientific world and beyond. News outlets scrambled to cover the unfolding story. Forums lit up with theories. Some claimed it was proof we are not alone. Others believed it was simply a strange natural phenomenon. But the excitement was undeniable. Digging deeper into the data, scientists noticed something else. The planet's orbit was unusually stable, too perfect to be explained by ordinary celestial mechanics alone. Additionally, the spectral analysis of the light suggested elements and compounds not found naturally on Earth, or even in our solar system. These substances had atomic structures that defied known models. One particular compound seemed to absorb nearly 100% of incoming radiation, a material far more effective than anything humans have yet developed. Such discoveries only deepened the mystery. Adding to the intrigue, thermal scans of the planet's dark side revealed hotspots, localized areas warmer than they should be if only natural geothermal activity were at play. These hotspots were arranged in geometric shapes, lines, triangles, even spirals. Could they be massive structures? Cities? Machines? We don't yet know. But what is becoming clearer with each scan is that something extraordinary is happening on that distant world. As more time passed, astronomers began to compare the new data with ancient sky records. They discovered something that left even the most seasoned scientists stunned. References to a moving star in ancient Sumerian and Babylonian texts appeared to match the same region of space. Could it be that this phenomenon has been visible, albeit dimly, since ancient times, and we're only now seeing it clearly with modern tools? If so, this means the light has been shining for millennia, a silent signal pulsing across the galaxy, waiting for someone advanced enough to notice. This isn't the first time strange signals have caught our attention. The famous "wow" signal, detected in 1977, for instance, remains unexplained. But this is different. This is visual. This is ongoing. And it's not a one-time event. The implications are staggering. If this is indeed artificial, it means there is, or was, another civilization capable of engineering planetary-scale technology. A civilization that might be millions of years ahead of us. And if they're still active, what else might they be capable of? In response to the discovery, the global scientific community began to mobilize. Projects that were once low priority suddenly received emergency funding. New satellites were repurposed to observe Lumina 4b. SETI increased their listening efforts. Universities formed special task forces. Think tanks speculated on everything from alien ethics to the potential for interstellar diplomacy. The conversation had shifted from, "Are we alone?" to, "What happens if we're not?" Public reaction was as intense as it was divided. For some, it was a dream come true, proof that we're part of a larger galactic family. For others, it was a source of existential dread. After all, if a civilization can build artificial light visible from across space, what else could they do? Are they peaceful explorers? Or watchers? Could their silence mean they're extinct, or simply not interested in communicating? Meanwhile, debates raged among scientists, philosophers, theologians, and politicians. Should we respond? If so, how? And who speaks for Earth? No consensus has been reached, but the urgency grows. Every day, the James Webb Telescope collects more data. And every day, Lumina 4b continues to shine. Despite the debates, one thing is certain: this discovery has changed us. It has reminded us that we are small, that our place in the universe is not as central as we once believed. It forces us to look beyond borders, beyond politics, and see ourselves as one species under one sky. And maybe, just maybe, this realization is the beginning of something greater. The team at Waves Discovery has been closely monitoring every update, translating complex scientific papers into understandable insights for all of you watching. Our goal is to keep you informed, curious, and inspired. Because this isn't just a story for scientists. This is a story for all of humanity. As the Webb Telescope continues its mission, many are already asking what comes next. Will we send a probe? Can we? Should we focus on developing faster than light travel, or more advanced telescopes that allow real-time observation? The questions are endless. But in this moment, as we look up at the stars and see one of them blinking back, we are reminded that the universe is not empty. It's alive with possibilities. So what do you think? Is Lumina 4b a natural marvel we've never seen before, or a message from the cosmos inviting us to look closer, think deeper, and dream bigger? As always, Discovery at 2.0 will be here to explore these questions with you, one discovery at a time.